simple polynomial division, okay? Being able to divide polynomials. We're going to step up on this. The first type you probably have done before, but I just want to make sure we're all on the same page and review our exponent rules really quickly. Obviously, if we have a problem like this, we need to divide each term by the monomial. You simplify coefficients and you subtract exponents. You go top minus bottom. The exponent that's on the top, you subtract the exponent that's on the bottom. So if we are going to divide this polynomial by 9n squared, personally, I kind of like to go through and just put each term over 9n squared. That way I make sure I don't miss anything. It's a lot easier for me to visually see what's going on. That's my suggestion. So 18 divided by 9, switch my numbers around there. 18 divided by 9 is 2. N to the fourth divided by n squared. Subtract those exponents. So that is n squared. 18 divided by 9 again is 2. And n cubed over n squared is n. And then for the last one, 3 over 9, not a whole number. But we do need to reduce that to 1/3. And n squared over n squared, cancel. What y'all like to say, but it equals 1, okay? And 1/3 times 1 is just 1/3. All right, let's look at another one, okay? Yes, this is very simple, but this one has a little bit of a twist in it at the end. Okay, so we're dividing each of these by 10r squared. So 3 over 10, not a whole number, doesn't reduce. So we just leave it, 3 over 10. R cubed over r squared is r. Make sure it's clear that that r is not in the denominator, okay? So you either need to write it very clearly like I have it, or this is the same thing. 3r over 10 is the same thing. And then it's very clear that r is in the numerator. Okay, moving on, 40 divided by 10 is 4. R squared over r squared is 1, plus 50 over 10 is 5. R over r squared, what do we do with that? We move it down, we move it in the bottom. So you can look at it as 1 minus 2 is -1, and negative exponents, we move them to the denominator. So that's 5 over r. So again, make sure it's very clear where your r is. Is it in the numerator, or is it in the denominator? Okay? All right, so let's go ahead and talk about dividing by a binomial. We'll do the simple cases today, and then we'll get to the more difficult stuff on Monday. So a binomial has 2 terms. The first process, we're actually going to look at 2 processes to do this, but the first one we're going to look at is synthetic division. Okay, so we start by setting the binomial equal to 0. We solve for the variable, and that number goes on what we call the shelf. We're going to list the coefficients of the polynomial beside the shelf. You got to make sure it's in standard form. And then if the remainder is 0, this is just kind of a side note, the binomial is a factor of the polynomial, and the number on the shelf is a root of the polynomial or an x-intercept. I'll explain that once we do an example here. Okay, so let's look at example number 1. We are dividing by v minus 3. So we set v minus 3 equal to 0 and solve for v. So 3 goes on the shelf. Okay, that's what the shelf looks like. It's a backwards L. Then we list the coefficients of our polynomial. So v cubed doesn't have a coefficient. It's understood to be 1. Then -13. 29, and 9. It's very important to make sure that those are listed in standard form. So you go from highest exponent down to a constant term. If anything is missing, say for example, we didn't have 29v, you have to put a 0 as a placeholder. Okay, say the 29v was missing, then we would have a 0 where the 29 is. You have to do that, or else it throws off your whole problem if you don't do it. So then you need to leave yourself a blank line and then draw a line. Okay, leave you a blank space because we're going to put some numbers there. Draw a line. Okay, here's the process. That first coefficient, it just comes down under the line. Then we multiply that number by the number on the shelf. So 1 times 3 is 3. We're going to add. Negative 13 plus 3 is negative 10. Then we repeat the process. Multiply. Negative 10 times 3, negative 30. We add. 29 plus negative 30 is negative 1. Then we multiply times 3, so that's negative 3, and we add, and we get 6. That last term down there is always the remainder. Okay, and then to label our answer here, because right now we just have a bunch of random numbers, okay, we reduce the degree by 1, so we started with v cubed, so we go in and we've got v squared, v, and a constant. So here's how we should write our final answer. V squared minus 10v minus 1 plus our remainder over our divisor, what we divided by. Okay. Remember back, go way back to elementary school, because y'all are so old, right? Go way back to elementary school. Remember when you did long division and you divided numbers by numbers, and then at the end you put the remainder over what you were originally dividing by? That's what we're doing right here. We're putting the remainder over what we originally divided by, okay? So that's how we express this. We did not have a remainder of 0. So what that means is if we could have factored that original polynomial, v minus 3 is not one of its factors. Okay, because the remainder was not 0, v minus 3 is not a factor. Positive 3 is not an x-intercept of that polynomial. Okay, let's look at another example to make sure we've got it. N cubed minus 6n squared minus 17n plus 70 divided by n minus 7. So we take our divisor, set it equal to 0, solve for the variable, 7 goes on the shelf. Okay, pretty much every time you're going to change the sign. But I go through that process because we're going to get to some eventually where it's like 2n minus 7. Okay, so it's not just the 7, you got to divide it by 2. All right, let's list our coefficients. We've got 1 again, negative 6, negative 17, and 70. We're not missing any terms, and it was in standard form, so we're good. All right, bring down the first coefficient. So that's a 1. Multiply by the number on the shelf. That's 7. Add. Negative 6 plus 7 is 1. Multiply by the number on the shelf. 1 times 7 is 7. Add. Negative 17 plus 7 is negative 10. Multiply by the 7 on the shelf. Negative 70. Add. We get 0. So we label it. We reduce the degree by 1. We started with n cubed, so we've got n squared plus 1n minus 10. So the remainder this time was 0. So our answer is just n squared plus n minus 10. So what that means is that cubic function is factorable. Okay, it is factorable. N cubed minus 6n squared minus 17n plus 70 is equal to n minus 7 times n squared plus n minus 10. You just learned yesterday how to multiply that out, or you reviewed yesterday how to multiply that out. If you don't believe me, you can multiply it out and it will give you that polynomial. Okay? It's just like dividing with regular numbers. If I divide 18 by 6, I get 3. So that means 6 times 3 is 18. So when I divide this polynomial by n minus 7 and I get this answer, it means n minus 7 times my answer gives me the polynomial. If I were to graph this polynomial right here, guess where one of the x-intercepts would be? 7. One of the x-intercepts would be 7. When I plug 7 into that polynomial, the answer is going to be 0. Okay? So there's lots of good stuff that you learn from polynomial division when the remainder is 0. You learn stuff about the graph, you learn stuff about the solutions, okay? So I think that's everything that I need to cover that means. Okay, let's do one more just to make sure we've got it. Okay, r minus 5, so that means 5 goes on the shelf. Our leading coefficient is -1 this time, switching it up. So that was to the 4th. Cubed is 14, squared is 36. I'm missing r. You have to put 0 between the -36 and the 19. If you do not put 0 right there, you will not get the correct answer. It'll be close, but it won't be the correct answer. Okay? So you got to be careful. Don't try and do these too fast. Bring down the -1 this time. -1 times 5 is -5. Add, we get 14 minus 5 is 9. Multiply, we get 45. Add, we get 9 again. Yeah, 9. Okay, multiply, we get 45. Add, we get 45. Multiply, I'm not going to risk doing that in my head. 45 times 5. 225? Yeah. Okay. 225 and add 19. 244. Okay. I don't want to say getting a remainder that big is super rare, but it is kind of rare. Usually your remainders are going to be pretty reasonable, pretty close, and not crazy. But sometimes it happens. So r cubed, r squared, r constant. So the answer is -r cubed plus 9r squared plus 9r plus 45 plus 244 over r minus 5. Now, we didn't have a negative remainder, but it is possible to have a negative remainder. So if you have a negative remainder, this plus right here before it is just a minus. Okay? If your remainder is negative, then this plus here at the end turns into a minus. That's the only difference there. Okay? I didn't do anything wrong with my numbers, did I? You're right? Okay. It just freaks me out when there is that big of a remainder. Okay? It is possible, but it's just a little